Hello everyone, this is Jyotishan from the Ascend the Pathway of Education. Welcome to another new video. And as I have told in the previous video of metals and non-metals, the third chapter of chemistry, that I will bring a separate video on the extractions of metal. Okay, so I promised you guys that I will make a separate video on the portion extraction of metals, because I thought that I think that this is a portion, that is extraction of metals is a such a portion which cannot be covered in one video with the other parts. So I just thought of making another separate video on this topic, because it's a huge topic and this is one of the most important topics you will be facing in the chapter metals and non-metals. So I think it actually has a separate theory, separate practical. Okay, and there are many charts also you have to learn: calcination, roasting, sulfidose, many more. Okay, so in this video we will see how to extract metals. Okay, so the chapter's name is metals and non-metals. Those who haven't seen the other theory portions of this metals and non-metals chapter, please visit my channel, the Ascend the Pathway of Education, and see the previous theory video, and also you will get many more videos on the chapters or the syllabus of class 10 science CBSE board. Okay, so we have already done this chapter, metals and non-metals. Actually this is the last portion of this chapter on your NCERT book. So actually this is the separate video. Okay, not like that I am starting this chapter now only. I have already done with this chapter, but this portion I haven't covered in that video, because this is a very complicated portion, to be very honest. Okay, extractions of metal. I hope it is clear. Let me check. Yes, it is clear. So ore, that is concentration of ore. We all know that metal is not extracted from the beginning only. We get metals in other forms with involvement of dust, dirt, okay, and many more things. So we have to do cleaning. So those particles have to pass through many of the processes to get refined to a pure metal. So we will see what are those processes to transfer those concentrations of ore into a purified metal. Okay, so there is a three kinds of metals we will see. Metals of high reactivity, I would like to request everyone, those who are seeing this video, to please copy this chart, because this may come in your exam as the flow charts. Metals of high reactivity, and the other portions will be given. So here will be a dash. What is this? So please note it down. Metals of high reactivity, metals of moderate reactivity, and metals of low reactivity. Okay, three kinds of metals: metals of high reactivity, metals of moderate reactivity, metals of low reactivity. So how what is the first process by which metals have to be passed which are very high reactive? Okay, the metals which are very high reactive, so those kinds of metals have to pass through the electrolysis of molten ore first. Electrolysis of molten ore. Electrolysis of molten ore, then I think it is clear. Refining of metal, then we will get a pure metal. So what are this? Four portion: metals of high reactivity, electrolysis of molten ore, refining of metal, then pure metal. Metals of moderate reactivity. There are also subparts between these two. One is carbonate ore, which contains carbon in it. Carbonate ore. And another one is sulfide ore, that is which contains sulfur in its ore. Sulfide ore. Okay, so here calcination for the carbonate ore, for such metals which contains carbon in its ores, the second process for them will be calcination. From carbon it comes to carbonate ore, from carbonate ore it comes to calcination. Remember by using the names. Calcination. Okay, and in sulfide ore, for them the third process for them will be roasting. You can't perform roasting with carbonate ore, you can't perform simultaneously calcination with sulfide ores. Okay, and after that again, then after calcination and roasting, all the ores, despite of containing carbon and sulfide, all are purified. Not purified, there are oxide of metal. Oxide of metal. After these two processes, calcinations and roasting, we will get metal in the metal oxide, such as calcium oxide and all. Okay, oxide metal, then purification of metal. Please note it down. I know it's very funky, so please note that metals of moderate reactivity. From there it is getting two subparts, carbonate ore and sulfide ore. For carbonate ore, calcination; for sulfide ore, roasting, and after that both the things converted into oxides of metal, and after we get the oxides of metal, we will perform the purification of metal, so that oxygen is reduced and we get only the metal form. Okay, that is, as I told, that calcium oxide. So we will perform a process by which CaO, the O is reduced, that is oxygen is reduced, and only the Ca is left with us, that is the only calcium, the only metal. And metals of low reactivity, sulfide ore. One thing is to be noted, that in the case of metals of low reactivity, only the sulfide ores are present, that is in their ore only sulfide is present. Okay, not any kinds of further sulfide Then roasting, same one, sulfide ore roasting. Metal oxide, then pure metal. So I hope this gets clear to you, and also I will give a picture in this video after this clips ends. So from that will be a clear one, and also you will get in your NCERT book, though I will give you a clear picture so that you can note it down. I know from here noting down is little difficulty, I can understand, so that's why only I will put a photo. Okay. And after that we will see some definitions. Concentration of ores. I've already explained to you, but still you need to know the definitions, the theory one very clearly, so that you can learn and write your exams. So that's why what is concentration of ores? The process of removal gangue particles from the ore is known as concentration of ore. This is one of the process. Concentration of ore is the process of removal. It is mainly removing the gangue particles. What you will say? What are the gangue particles, sir? Gangue particles are the dust and dirt. Okay, as we all know that we extract those ores from inside our ore, so obviously it will not pure. Many things will be involved: dust, dirt, leaves and all, dead animals, decayed animals. So removal of such materials, and such materials are conveyed with the gangue particles in this question, in this answer. So the process of removal of gangue particles from the ore is known as concentration of ore. The process of removal gangue particles from the ore is known as concentration of ores. Please note it down, I am repeating again. The process of removal of gangue particles from the ore is known as concentration of ores. Now we will get the definitions of gangue or matrix. This also I have already explained what are the gangue particles, that is the dirt portion, but still, gangue or matrix. Gangue is the similar word to matrix, so please don't get confused in it if it comes in your exam. Matrix and gangue are the same things. The ore mined from the earth crust contains some unwanted substance or impure, such as sand, rock or clay materials. Such substances are known as gangue or matrix. The ore mined means which at the time of extracting, the ore mined from the earth's crust. You have read this crust in class 7, and also in class 8 also you have read in geography. Earth's crust means the inner portion of the earth. The ore mined from the earth's crust contains some unwanted or impure substances known as gang or matrix. Okay. Now we will note this para, that is K, that is potassium, Na sodium, calcium, magnesium, aluminium, zinc, Fe, Sn, Pb. What are these? Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin and Pb, that is lead, plumbum. Potassium, please note it down. Okay, first let me mark all these things, then you will write. The top two, that is potassium and sodium, comes under the high reactivity metal. So for this two, for only these two metals, that is potassium and sodium, we will apply the first one. Please remember in the flowchart I have drawn. First, electrolysis. Only the first one, extractions of metals of high reactivity. So that process we will apply in this two. Then up to Fe, that is from calcium to Fe, comes under moderate reactivity. For this 5 elements or the metals, we will apply the process of moderate reactivity, and the last two, low reactivity. I hope it gets clear to you. Okay. Now we will see extractions of metal of high reactivity. Extraction of metal of high reactivity, that is this two, potassium and sodium. First, we all know that oxides are, we get in this oxide form, that is K2O N2O, sorry, Na2O, not N2O. Potassium oxide, sodium oxide, they will only be separated by giving electric current, that is electrolysis. Potassium or the sodium will only get separated from the oxygen by the process electrolysis, that is supply of current. Okay, and now what is this process? Please note it down. First process is the K2O and Na2O. We get these two compounds in this form, in their oxide forms, and they are separated from the oxygen only in the process of electrolysis. Electrolysis process, that is the supply of current. Now how electrolysis is performed? Okay, so the first one we will get in the Cl, that is chloride, NaCl, sodium chloride. Okay, it's not possible to show both of them, but the process are same for both of them. I will show as the example of NaCl, sodium. First we will take a beaker. Straight one. Beaker. We will first fill this beaker with the molten NaCl. We all know molten means it is semi-liquid. So this liquid portion is molten NaCl. Okay. We all know that in the process of electrolysis there are two nodes involved, that is cathode and anode. This is a circuit. It is anode and it is cathode. Cathode means negative charges. Negative, and this means positive, anode. Okay, right here, negative and positive. So what will cathode do? As it is negative in charge, it will attract the positive ones. Here it is NaCl. So what if we divide this? Na plus Cl minus. We all know this division. I am not repeating this one. We all know this one. This is the basic. We divide Na and Cl, that is sodium and chloride. We get Na of positive and Cl of negative. So it's a common sense. As it is negative, cathode is negative. It will attract the positive one. So what it will attract? What is positive here? Na positive. So in this molten NaCl form, there are so many Na plus, okay, and also Cl minus. As it is molten, the atoms got drifted from each other. There are many Na plus atoms and Cl minus atoms roaming in this molten form. So negative one will attract this. First let me rub this, it's getting tidy. It will be difficult for you to understand. For getting it a symbol of liquid, I am not drawing all those things. It's just a one. Na plus Cl minus, again here Cl minus. This kind, such millions are roaming inside this in molten form. As it is positive, it will attract the negative one, that is Cl, chlorine. It will attract over here, and as cathode is negative, it will attract positive one, that is sodium. So what we will get in cathode? In the cathode bar we will get the sodium Na plus, and in the anode bar we will get Cl minus. Why? Because cathode is negative and anode is positive. Okay, complete. So where we are actually getting the metals? Where? At cathode. In cathode only we are getting Na, that is sodium. In this Na and Cl, Na is the metal. We are getting metal in cathode, so we can take the metal from the cathode only. We don't need to see in this anode portion. Chlorine, we don't need chlorine, we need cathode, that is sodium. Sodium is restricted to cathode bar, and through the cathode bar we can extract the pure sodium form. Okay, now extractions of metal of moderate reactivity. Extraction of metal of moderate reactivity. We have done with the high reactivity. Now we will see moderate reactivity. What is the first? That is the reducing agent, and the first process will be we are getting into carbonate or sulfide, that is calcination and roasting later on, but the first process will be performing and reducing agent. And what will be the reducing agent of this elements? Carbon. We will reduce all this, that is the loss of oxygen. Reducing agent carbon. Okay, that is all these are formed in oxide ZnO plus C. We all know reducing agent is the agent for whom reducing is caused, not on whom reducing is caused, but for whom reducing is caused. So ZnC plus O, that is sorry, metal will be separated plus CO2, C plus O, that is CO2, carbon dioxide gas will be evolved and metal is extracted. Okay, and now what is smelting? First we will see the theory portion there, and then we will see the calcination and roasting. Okay, what is smelting? The reduction of metal oxide to metal by using carbon as a reducing agent. Reducing the metals by using, that means melting. The process melting took place in this whole reaction because we have used carbon as a reducing agent. Reducing the metal by using carbon as a reducing agent. Okay. Now we will see extractions of metal of low reactivity. Of low reactivity, that is Sn or Pb, that is tin and lead. Using carbon monoxide as a reducing agent. In the case of moderate reactivity, we have used carbon as a reducing agent, and in the low reactivity of metals, we will use carbon monoxide as a reducing agent. Okay, so PbO plus CO, carbon monoxide, that is CO, and PbO, lead oxide. So what will happen? CO plus O, Pb plus CO2, CO plus O, that is CO2, carbon dioxide. In the same way, carbon dioxide will be evolved, and we are getting the pure lead form. Okay, complete. These are the reactions one. Okay, these are the reaction one. You will say that, oh, it's complete, it's too easy. No, it's not too easy. We are left with the two more portions, two different portions, that is calcination and roasting. Okay, what is roasting? Okay, clear this one also. We don't need this one. What is roasting? Roasting is the process in which a sulfide ore is heated below its temperature, below its melting point, in the presence of excess air to convert it into metal oxide. Okay, so it is the process in which a sulfide ore is heated below its melting point Okay, the steps I have shown before this one, that is, if you have noticed that we all have, in each and every case we have started with the oxides of metals, PbO, and then transforming it into a pure metal. Then you can say that, okay, we are already getting the pure metal. What is the importance of this two, calcination and roasting, and how we will get that oxide? We are not getting it into in the oxide form. We have to transform it into the simple oxide form. So before that, so as I know, I have kept roasting and calcination in the last portion, but it is it's actually the first step of converting those metals into the oxide one. So those steps come after this process. Okay, so melting points in the presence of excess air to convert it into metal oxide. If I give you an example, then you can understand more clearly. Suppose Zn, okay, zinc, it comes under the moderate reactivity one. So as it is sulfide ore, we all know, as I have told, that sulfide will be present in its ore, ZnS plus O2. Why we are adding oxygen? It is written that is heated below its melting point in the presence of excess air. What is the meaning of excess air? In the presence of excess air. Okay, that is plus O2. if it is written that absence of air, or in the absence of or in the presence of lack of oxygen, there we have to just heat, not we have to just add also. Okay, go step by step, you guys will not understand. ZNS plus O2, ZNO plus SO2. Okay, we have seen that from the zinc sulfide we have got the zinc oxide one, and now we will see that process. As we are getting the zinc oxide one, we will perform smelting. Remember, smelting, ZNO plus C, that is using carbon as a reducing agent. Zn, we are getting the pure Zn form. Recall those things. Zn plus CO2, carbon dioxide gases evolved. Okay, as we are heating this, and this is a symbol of heating, so please give this above the arrow. This is step 1, this is step 2, and in this video I have shown this step 2 before the step 1. Okay, because I wanted to show the easier portion at the first of this chapter. Okay, so transforming zinc sulfide into zinc oxide through the process of roasting, that is heating, in the presence of excess of air. In the presence of excess of air, there we are getting that zinc oxide, that is oxide form of metal, zinc oxide, and then we are performing the process melting, ZnO plus C, that is using carbon as a reducing agent, ZnO plus C. Zn, we have extracted the pure metal C, not ZnOs, not ZnS, not ZnC, anything, nothing. We have got the pure one, only Zn, that is zinc plus CO2. Understood? Now we will see roasting. Calcination. Calcination is nothing but the opposite of roasting, that is metals are heated below its melting point in the absence of air, not in the presence of air, in the absence of air. Okay, calcination, metals are heated below its melting point in the absence of air. What do you mean by absence of air? We will not write, that is plus O2, we will not add oxygen. Below its melting point in the absence of oxygen, to transform it into metal oxide. Okay, we have to take an example which where carbonate is present, same one, that is zinc carbonate. Zinc carbonate, we will not write further plus O2, we will just give an arrow, that is heat, Zn O plus CO2. Oxygen, 3 oxygen is present, 2 in the carbon dioxide, 1 in the zinc oxide. Okay, sometimes zinc is present in the sulfide ore, with the sulfide ore, and sometimes it is present in the calcinate ore. Okay, as in the same process we will also perform the next step, that is remember this step I have shown, just I am repeating again. as we have got the zinc oxide, that is oxide 1, zinc oxide plus carbon smelting, Zn plus CO2. Finished. Step 1, step 2. First, letting the zinc carbonate transform itself into the zinc oxide by heating. In the absence of oxygen, we are getting the zinc oxide 1, that is the oxide form of metal, and then we will perform the smelting process, ZnO plus C, that is using carbon as a reducing agent. We are getting the pure zinc 1 again in the calcination process, and carbon dioxide gases evolve. Finish. I know it's not too tough. But yeah, the things you have to remember, such as calcination, the process of calcination, process of roasting, what is roasting, step by step. Okay, so I don't think this will take very time to learn. Please follow that flow chart very carefully. I will upload a picture. Please follow that, please note it down, please go through that flow chart at least once in a week in the while revision. I know class 10 is a huge syllabus, so revising a single thing many a times will not work, but at least you have to try to revise each and every chapter at least once in a week. Okay, step by step in the flow chart, remind just step by step, and then just relate with these equations, with these reactions and equations, and then I'm damn sure you can score a good marks, and also you can remember all those things. The main thing is remembering. Okay, so yeah, we came to the end of this, we came to an end of this chapter, of this video rather. So I hope you all have understood this portion very clearly. I hope there should not be any problems, but if any problem arises in your mind, please don't hesitate to confirm this to me. Please let me know in the comment section, and thank you very much for being with me for such a long time. And also we have crossed a 1 month anniversary. I know I will bring a video, but till that take care of yourself, and I will bring the next video on the next chapter of the chemistry, that is chapter number 4, carbon and its compounds. It is a very interesting chapter, and also it is one of the easiest chapter, but the last portion is little difficult, but the first one is very easy. Okay, so till that, take care of yourself. Bye bye.